In this short video, let's think about what happens on the molecular level when a substance boils, and also what does not happen. The animations are crude, but they get the point across. As our example substance, we're going to use ethanol, C2H5OH, and alcohol. It has a boiling point about 78 degrees Celsius. What is the boiling point? Well, above liquids, even below the boiling point, a small amount of the molecules of the liquid vaporize. We see this is true with water. Even above ice, sometimes if it's very cold, you can see a little bit of a cloud of fog above the ice, because even the ice has a vapor pressure, and cold air will cause that to then condense into small water droplets you can see as a cloud. So above any liquid, there's going to be a little bit of that liquid as a gas, a little bit of the gaseous compound above the liquid surface. We call the pressure of that gas a vapor pressure. The higher the liquid temperature will be, the more molecules will be in the gaseous phase, because of course the kinetic energy is higher, and therefore the higher the liquid temperature, the higher the vapor pressure. Now, this is a graph of the vapor pressure of ethanol as the temperature of the liquid changes. And you can see as it goes up, the temperature goes up, the vapor pressure goes up. The boiling point, as you see here, is the temperature at which the vapor pressure equals the outside air pressure. And you can see that's about 78 degrees. Now, below the boiling point, the molecules are vibrating and they're rotating and they're staying close to each other. They're held in place by intermolecular forces, forces between the molecules. A few will vaporize, but the vast majority will stay in the liquid phase, held together by those intermolecular forces. That's not true when you get to the boiling point. Watch. At the boiling point, the molecules all over the liquid get enough energy to escape, and when they do, they'll form bubbles of the gaseous substance throughout the liquid. What is happening is the intermolecular attraction that is keeping them in the liquid state. Because of the energy that's available, the intermolecular attraction breaks, and the molecules then escape into the gaseous phase. That's what happens in boiling. Whatever is boiling, that is what's happening to it. As you can see, the molecules stay together. That is, the carbon-carbon, carbon-oxygen, hydrogen-carbon, and oxygen-hydrogen bonds do not break, but the force of attraction between the molecules breaks. This is not boiling. As you can see, at temperatures much higher than the boiling point, the covalent bonds holding the molecules together rupture. This is a chemical change. Boiling is a physical change. Intermolecular attraction is breaking, and the molecules break off and become gaseous. If we were then to collect the vapor, the gas that comes off in boiling, and cool it, we get the liquid substance again. The liquid substance is the same as it was before because the chemical formula hasn't changed. But if we heat the substance so violently that we break the molecules themselves apart, we break up the covalent bonds that hold the molecules together, then we can cool it all we want, but we will not bring back the original substance. From the C2H5OH, we'll get probably some black carbon residue and water vapor coming off, but we will not get the original ethanol.